today I'm going to study microcontrollers, and first of all I'm going to copy paste the course content into Gemini, and then get some kind of short answers for me. I think at least 30 minutes would be enough. I need to get into the track. So till I get into the track, I will just do this right here, and then after that I will just work on my one, because my two of my phones batteries are dying, and because of the heat it caused by going live, and also the data uh, vanishes, like it just, I don't know, it just vanishes the moment I start doing live. Like it just, I take more data than it should be, so it is not a good habit since I don't earn at the moment. So yeah. Give me give me short answers. Give me short answers for this, thinking of someone who is just trying to understand things, and a beginner. So thinking like that, just summary kind of a explanation of each and every topic from here should be given. What is an embedded system? Embedded system is it is specialized computer system designed to perform one specific dedicated function to or task, function or task, rather than being general purpose computer like a laptop. It combines hardware and software. Okay, I'm gonna write it from. I'm gonna write it in this. Yeah, I'm gonna write it in this. So I have wrote something not uh, necessary for this topic. So I'm gonna remove these two pages and add it to the that particular book set. So this is that book set. So I'm gonna add it in here. Then this is my watch. You can see the time. Can you see it? I can see it. I think you can see it now, but I can work with it. Okay, this is good. So these are the two books that I choose to write in this write about the module microcontrollers. So I have wrote several things. Yeah, I'm going to go backward. So in here I'm going to write these topics. What is an embedded system? Microprocessor versus microcontroller. Microcontroller families, PIC microcontrollers, microcontroller architecture, parallel port interface, power supply, clock oscillator. Yeah, these are things like that, and also Programming and software fundamentals, parameter parsing, global variable, local variable, interrupt handling, and development and communication, introduction to development environment, serial port USAR, data acquisition and manipulation, system C for microcontroller programming, queue management, resource management, real world application design examples. Yeah, there are several things that I need to study one by one. So first of all, what is an embedded system? Should I write it on this paper? No, I should write this one. What is an? This is a calendar paper that I using. This is a calendar paper because I ran out of money. I don't want to waste money. I just uh, took some old calendars and I'm write on them because it is not a waste of money. What is an embedded system? What is an embedded system? Embedded system is a specialized computer system. It is a specialized computer system designed to perform one specific dedicated function dedicated function or task rather than being a general purpose computer like a laptop. It combines hardware and software. This is what Gemini says, but let's see what our lecture side says. Um, I need to compare all of them and try to figure it out what is the most suitable thing to write in the exam. So our lectures like saying like it is like pointing out some important details, right? It is application specific computer system. Embedded system is an application specific computer system and it is a component of a large system and it interacts with its environment and it often has real-time computing constraints. Okay, it often has real-time computing constraints. An embedded system is a specialized computer system with chip embedded hardware. There are no standard definitions for an embedded system, but principally it can be defined as a hybrid pre-processing and compute system with a task-specified design which interacts with its environment. More simply, a system whose principal function is not computational but which is controlled by a computer embedded within it. Usually, embedded systems are designed because the repeating task has to be performed either periodically or spontaneously with low cost and power high performance. Okay. So they are pointing out four things: application specific computer system, components of a large system, interact with its environment, and often has real-time computing constraints. So what I'm going to do is that I am going to copy paste these two pages to Gemini 2 and then ask Gemini ask from Gemini that what is the most suitable answer, the thing you gave me or this. I think our thinking capacity is vanishing because of these things. But anyhow, I need to pass this exam. Um, let's what do you think? What is more suitable thing to write on the paper? Like the thing that Gemini gave me, or this? What is the most suitable thing? Let's see. Hey Gemini, this is our lecture. This is what our lecture slide says about what is an embedded system. So between the answer you gave me and between the answer you gave me and the lecture slide, uh, can you tell me what is the most suitable answer to tell write on the exam? An embedded system is an application specific specialized computer system with chip embedded hardware whose principal function is not purely computational but is instead controlled by a computer embedded within it. Key characteristics are environmental interaction, system integration, design objectives and constraints. Application specific, interacts with its environment, real-time computing constraints, low cost of power. So I'm gonna write that down too. So what is an embedded system? Application specific or specialized computer system. An embedded system is an application specific or specialized computer system embedded system is an application specific or a specialized computer system with chip embedded hardware um, whose principal function is not purely computational whose principal function is not purely computational uh, but is instead controlled by a computer embedded within it but is instead controlled by a computer embedded within it. Okay, this is what I'm gonna write on the paper. What is an embedded system? An embedded system is a task specific, application specific, or a specialized computer system with chip embedded hardware, whose principal function is not purely computational, but instead controlled by a computer embedded within it. Okay. Next question. Key characteristics. First of all, I need to find out the past papers. Let's try to find out the past papers first of all. Okay, past papers. Yeah, here it is. We got one past paper. I think that we have two past papers, but here it is. So, what's an embedded system? Describe using block diagram. Okay. Like I have been studying this since like so many days. So, I think uh, even I just got answers for this question also. Look, I wrote answers for this question. So what I'm gonna do is um, like I wrote answers for it, right? Yes, I wrote answers for it too. So it is like if I keep doing this question, it is like repeating the only one question again and again and not covering other things. So what I'm gonna do is that I will write the embedded system definition here, like explanation about embedded systems, and then we'll move on to the next question because otherwise I will waste my time. So there's the rest anyway. So I'm gonna write down the explanation about what is an embedded system. An embedded system is an application specific an embedded system is an application specific or a specialized computer system with chip embedded hardware An embedded system is an application-specific or specialized computer system with chip-embedded hardware whose principal function is not originally purely computational. Uh, whose principal function is not purely computational, but is instead controlled by a computer embedded within it. Okay, huge explanation is here. But okay, now I'm going to move on to the next question because otherwise I will waste my time. So the next question would be like I completed first question only, which means yeah, which means I need to go from the second question. So the second question is asking what is using suitable diagrams describe the differences between microprocessor and microcontroller. So let's write that down. Second question, A part. So I will put this to Gemini again because it is in this way it is easy, very easy, it is easy. I know our thinking ability and everything is vanishing, but still this AI gives us lots of benefits, so I should take it. So what is the difference between microcontroller and microprocessor? Let's just try to find out. Okay. There is architectural diagram also. I will come to it later. So first of all, just um, compare the key differences. The first thing is microprocessor, and then microcontroller. Microprocessor and then microcontroller. And I will write down the key features also. So first of all, it is explaining about integration. So contains only central processing units, RAM, ROM, time, and I/O ports must be connected externally. Combine CPU, RAM, ROM, timers, I/O ports onto single integrated silicon chip. Okay, microprocessor must be connected externally. I/O ports must be contains only central processor unit. All right. Integration. Integration in a microprocessor, it contains only central processor unit only. Okay. Contains the only contains only the central processor unit. It contains only the central processing unit. RAM, ROM, timers, I/O ports must be connected externally. RAM, ROM, timers, input output ports must be connected externally. Alright. And the second one is microcontroller. Microcontroller combines CPU, RAM, ROM, timers, and I/O ports onto a single integrated silicon chip. Microcontrollers combines the CPU, RAM, ROM, timer, input output ports onto a single integrated silicon chip. Yeah, that's the first difference. Microprocessor has only CPU and RAM, ROM, timer, input output ports must be connected externally. But on the other hand, microcontroller has CPU, RAM, ROM, timer, input output ports all together combined in a single silicon integrated silicon chip. Not microchip, I don't know microchip or not, but it is input output into a single integrated silicon chip. Uh, application. When you come to application, microprocessors are designed for general purpose computing tasks where high flexibility and processing power are needed. Designed for general purpose, designed for general purpose microprocessors are designed for general purpose computing tasks. Microprocessors are designed for general purpose computing tasks where high flexibility and processing power are needed. Um, like laptops, desktops, likewise, things like that. On the other hand, the microcontrollers designed for application specific embedded tasks. Designed for embedded tasks. Application specific embedded tasks designed for application-specific embedded tasks with a fixed repetitive function. With a fixed repetitive function, washing machine, microwave ovens. As example, these are examples. Washing machines, microwave ovens, things like that. So on the other hand, the microprocessors as examples, laptops, desktops. So laptops and desktops includes processors, but ovens, washing machines, microwaves include microcontrollers. So there are two different things, laptops and desktops. So application wise, the microprocessors are designed for general purpose computing tasks, but microcontrollers are designed for application specific embedded tasks. General purpose computing tasks, but application specific computing tasks. So that's why microprocessors are including in computers and desktops, and microcontrollers are including in washing machines, microwave ovens, things like that. So next one is cost and space and power consumption. So let's just think about the power consumption. When it comes to power consumption, uh, microprocessors use high power. It needs high power consumption because due to external components. As I said previously, microprocessors has only the CPU. It needs to add timers, RAM, ROM, and uh, input out ports and everything externally. So because of that, the only thing that it has is CPU, and other things are connected externally. Because of this, high power consumption is needed. So having high power consumption because external components are running across an external system, but at high speeds. Yeah, that's it. So high power consumptions due to external components. High power consumption due to external components running across an external system. High power consumption due to an external components running across an external system bus at high speed. And also I need to mention that it is very high. It is having high speed because they are connected external now, uh, so they need to provide the data very speedily other than the internal ones, because it is external and it should not have a delay. On the other hand, microcontrollers has low power consumption, making it ideal for battery operated devices. Many feature energy saving sleep modes. Features energy saving sleep mode. Okay. Many features. That means microcontrollers has a sleep mode to save energy. Many feature energy saving, sleep mode. So when it comes to memory and capacity, feature large and upgradable external memory capacity, typically measured in gigabytes, but in microcontrollers, it features fixed limited internal memory capacity, typically measured in kilobytes or megabytes. Memory capacity features large. Microcontrollers features large, upgradable external memory. This features fixed limited internal memory capacity. Cost wise, cost and space. Overall system is more expensive and takes up more space. So all, like, after considering all of this, we can have a conclusion like microcontrollers are better sometimes. Overall system is more expensive and take up more space. Overall system is more expensive and takes up more space due to requirement of multiple external peripherals ICs on the PCB. This system is highly compact and cost effective in microcontrollers. Microcontrollers is the system is highly compact and cost effective because everything is self-contained on one chip. The system is highly compact and cost effective. The system is highly compact and cost effective because everything is self-contained on one chip. Yeah, I'm done writing that. So before moving forward, let's just re-memorize it. So it will be easier for me. Microprocessor and microcontroller. Microprocessor contains only central CPU, but RAM, ROM, timers, input-output ports should be connected externally. Microcontroller, it has RAM, CPU, RAM, ROM, input-output ports, and everything connected to a silicon chip, integrated single integrated silicon chip. Application wise, microprocessors are designed for general purpose computing tasks. Microcontrollers are designed for application specific embedded tasks designed for general purpose computing tasks with high flexibility and processing power. Mm. This has high power consumption. This has high power consumption. But microcontrollers has low power consumption and it is compact, and microprocessors take so much space because it has some external things to connect, no, so it takes so much space and it has high power consumption. But microcontrollers on the other hand highly compact and it does not cost effective. Yeah, capacity. Microprocessors has feasible. The only disadvantage microcontroller has is it has fixed limited internal memory capacity. On the other hand, the microprocessors has large upgradable external memory capacity. That's the only positive sign of microprocessors. Microprocessors are expensive and overall system is but microcontroller is not so expensive. Yeah. So that's it for that question. So let's move on to the next question. Part B, what is mean by microcontroller family? Describe using suitable diagram. So I think for this I need to go for my lecture slides. Before that, let me charge the laptop. You gonna My friends are saying, shut up, Jenny, just get in the car. I just wanna be right where you are. In the end, I hope it's you and me. This is a study live, even though I'm screaming songs. Yeah, what does it mean by microcontroller family? So let's just try to find out it using my lecture slides. So let's just scroll through it. So there are several applications, embedded computer, yeah. Where is this microcontroller family? they have some kind of a graph that they have divided embedded devices into some several categories. So I don't think this is the microcontroller classes. Like this is where they divided embedded system, not microcontrollers. So what are them? I guess it is in the next slide. There are several things I need to study, man. Like study means like just we just memorize things. I don't think it is good, but somehow I need to survive in this exam. So yeah, I think microcontroller families. Yeah. Oh yeah, microcontroller types of. Okay, microcontroller families. Oh, this is it. So this is it. This is the only explanation it has. But first of all, let's just copy paste this again and try to find out ChatGPT's answer, and then I will give it to the me again the lecture slides, and I will try to get the answer also. Yeah, let's try to find out the answer. So in here, definition of microcontroller family. A microcontroller family refers to a group of microcontrollers produced by a single manufacturer that share a common core architecture. Processing unit design, instruction set, and internal bus structure, while fundamental brain remains identical across the family, individual memberships, and uh, model. Yeah, this is it. So yeah, this is it. They are mentioning it like this also in the lecture slide. So this is pretty much similar to the it. Yeah. First of all, let's just try to find out what is microcontroller family refers. Microcontroller family refers to a group of microcontrollers produced by a single manufacturer. The microcontroller family refers to a group of microcontrollers microcontroller families refers to a group of microcontrollers produced by a single manufacturer. Microcontroller family refers to a group of microcontrollers produced by a single manufacturer that shares common core architecture. That share common core architecture. Common core architecture. Central processing unit design, instruction set, and internal bus structure. Central processing unit design, instruction set, and internal bus structure. A microcontroller family refers to a group of microcontrollers produced by a single manufacturer that share common core architecture, CPU design, instruction set, and internal bus structure. Those are four things. Four things. A microcontroller family refers to a group of microcontrollers produced by a single manufacturer that share a common core architecture, CPU design, infrastructure set, and internal bus structure. So those are the things. Microcontroller family refers to a group of microcontrollers that's produced by a single manufacturer that shares a common core architecture, CPU design, instruction set, and internal bus structure. Instruction set, CPU design, and internal bus structure. Alright. Microcontroller family refers to a group of microcontrollers produced by a single manufacturer that share common core architecture, manufacture instruction set, CPU design, and internal bus structure. Those are the things. So, if you want to like explain it in a diagram, like they are asking to describe using a suitable diagram now. So first of all, I read this and then try to understand it and then draw the diagram. So they are mentioning this thing. So while the fundamental brain remains identical across the family, individual memberships vary in their peripheral configuration to suit the different engineering constraints. These variations typically include memory capacity, pin count and packaging, integrated peripherals, like memory count, the difference in size of flash, memory program, RAM and EEPROM. So pin count and packaging, the ranging from small 8-pin ICs for simple tasks to 100 plus pin chips for complex systems. Integrated peripherals like variations in number of times, ADC channels, PWM models, and communication interfaces, things like that. So, this family approach allows developers to write code for one specific architecture and this family approach allows developers to write code for one specific architecture and easily scale their design up or down to a different chip in the same family without completely rewriting the software. Family concept diagram. So the draw hierarchical diagram to visually demonstrate how a single shared core branches out into different specific microcontroller models. Yeah, this is a microcontroller family. Shared CPU core address, microchip PIC, 16, model A, model B, model C. Low NIC, mid-range IC, high NIC, 8 pins, 1 KB flash, 64B RAM, no ADC, 1 times timer, 18 pins, 4 KB flash, 268 256 B RAM, 4 CH ADC, 2 timers, Model C high-end 40 pins, 14 KB flash, 368B RAM, 8 ADC, 3 timers. Yeah, these are things like that. So, like I just understood a little bit. Microcontroller from shared CPU core and shared CPU core and address. Shared CPU core and address. Microsoft as example like microchip PIC 16 is a one the microcontroller family that manufactures by some kind of a company. Yeah, so it is like a brand name. I thought it is some kind of thing that we need to learn, but it's a brand name, man. I never thought of it that way. It is a brand name. As I said, I'm going to do this for 1 hour and stop it because I don't want to destroy this battery in my tablet also. So let's just draw the graph also, diagram also. So in this, the diagram is like this: family 1, co P, family 2. Alright, family 3, core, core. Right. They share the same things, but the capacity wise and different things like different. So let's just draw one family. Family 1. So it has core and memory and properties. So like let's just draw it like this. So I would say this is core P and memory. They share the same core. That's it. That's a common thing. And the only other things are like they differ in the size and everything. Properties. Peripherals. Microcontroller family refers to a group of microcontrollers produced by a single manufacturer that share common core architecture. CPU design and instruction set and internal bus structure. ඒක තමයි තියෙන්නේ. එතකොට copy and then I am going to draw it a little bit big now. So yeah, this is copy again. Memory peripheral. Then I can draw like this: core, memory, peripherals. The sizes and everything is changing. Other than that, nothing is changing. So this is copy. This is memory. This is peripherals. In here also copy. This has huge memory and also peripherals. Okay, this is the one family. So it has same core. It has same core and core architecture, CPU design, instruction set, core architecture, CPU design, instruction set, and internal bus structure. Okay. Next one is family 2. So like the families can be different. So the same thing. So in this family, it has same core, a different core, but like if we consider this family, it all has same core, but it is unique to this family. So memory, peripherals. Now it can be changed from one thing to another. So it has core Q, memory, and peripherals. I would say like this: core Q, memory, peripherals, and then core Q, memory, peripherals. This is another family now. So likewise, I can draw some another family also. I will draw the family tree also. So it has some kind of core. I would say core R, memory, and peripherals. Core R, memory, peripherals. This time it is bigger. Now core Now core memory peripheral. Describe the four general on-chip input-outputs interfaces found in microcontrollers. Four general on-chip input-output interfaces. Four general input-output interfaces. What are they? I think this is it. Four general input-output interfaces, right? Let's see. Let's just again put this to Gemini and then try to get the answer from Gemini, and after that, if it is correct, I will write that down. Yeah, this is it. Digital input output ports, timer, analog to digital converter, serial communication timers. Yeah, it is correct. Serial communication block. Yeah, this is correct. So what should I write on this? So they are asking what does describe the four general on-chip input-output interfaces found in microcontrollers. So I need to write this down. So general purpose input-output port. I can write that down. Part C. We need to describe it. So first one is like I have studied this previously. General purpose input output pins are there, output ports are there, timers are there, and analog to digital converters are there. Serial communication blocks are there. So from this, I need to move on to some other things also. So this connects to other topics. So general purpose input output port. General purpose input output port. So it always the program allows the program to handle an input output signal used for a switch input or LED display. 2 more minutes left. 1 and 30 minutes. 30 seconds. Allow the program to handle an input output signal used for a switch input or LED display. Used for switch input or LED display. The second one is timer. So this has input output ports, timers, analog to digital converters, and serial communication blocks. So timer I would say measures the time used for LED blinking. Timer measures the time. It is obvious, right? Timer measures the time. Measures the time. Used for LED blinking or motor controls. Used for LED blinking and motor controller. Motor control. Analog to digital converter. Analog to digital converter converts voltage value to digital value. Converts a voltage value to a digital value. Used for data input from a sensor. For voice input. From a microphone. Converts a voltage value to a digital value. Converts a voltage value to a digital value and used for data input from a sensor or voice input from a microphone. Used for data input from a sensor. It is used for data input from a sensor or voice input from a microphone. Serial communication block. Serial communication block communicates byte data through a single communication line bit by bit. When I studied this, but I don't remember it. Oh, 1 hour is done. I think I need to end this. Even though nobody's listening, I am gonna say bye. So if there is somebody who will just watch my live afterwards, they can hear it. So yeah, goodbye. I'm gonna continue studying throughout the day. Of course, I need to do it because exams are coming up within 2 days. Yeah, it is very stressful and competitive. So and also complex. So I need to study. I have no breaks. I need to complete it. And other than this module, I have some other modules to cover before the exam date comes. Otherwise, I will end up failing that subject again. So I want to let that happen again in this lifetime. So I'm going to study from now onwards. Bye. Thank you for being with me.